1, I'm going to discuss about the basic rule or the basic derivatives rule. Okay, so the first one is constant. Constant rule is the any number or any real number, like for example, like whole number, natural number, or any. So derivatives of constant is equals to 0. Alright? So example, if you have derivatives of 5, that is equals to 0. So any constant number that is equals to 0. How about number 2, which is the constant multiple rule. Okay, the pattern is any multiply by a constant to the any function. Example is constant times the derivatives of your first function. Okay, the apostrophe there, it's we call it derivatives. So example of that is derivatives of 3x. So let's put this one outside. So 3 derivatives of x, that one. So therefore you have 3 derivative of x is equals to 1. Okay, because the exponent is 1, I will discuss about the rule of the power or the exponent. How will you make it, or how will you perform it? So that is 3 times 1 is 3. Okay. And then for the power rule, so derivatives of x raised to n, where n is our exponent. Therefore, you will have n multiplied by x raised to n minus 1. Okay, I'll give you example for this. So this is derivatives of x raised to 5 is equals to 5, which is your n, will be your, it's like a constant. Then the x here, and then your exponent will be 5 minus 1. So when you simplify that, that is 5x raised to 4. Okay, raised to the 4th power. So this is your answer. Okay, next. How about sum and difference? Sum and difference rule. Yeah. Okay, so we have here derivatives of f of x plus g of x, or plus or minus g of x. Okay, so that will be derivatives of your first function plus or minus if it's sum or difference. Okay, and the derivatives of your second function. So either you can apply from constant to power rule. So any of those first 3 rules. Okay. Example. Derivatives of 2x squared plus 6x. Okay. So this is sum. Okay, we have to perform first this one. This is 2. Okay. So we have two constant here. We have to put it here. And the next is we are going to perform this because this one is applicable for constant multiple rule and power rule. So this is multiplied by 2 because of the power, and then x, then 2 minus 1. Then plus, I'm just showing it to you. So plus 6 times 1 because the derivatives of x is 1. Then let's simplify. So 2 times 2 is 4, then x raised to 2 minus 1 is 1. No need to write 1 there. And then plus 6. So the answer is 4x plus 6. How about minus or subtraction? Okay. So this is x squared minus 1. So how will you make this one? So first is the x squared. So you are going to apply the power rule. So the exponent or the power is 2. Then the x, 2 minus 1 is 1. No need to write 1 here. Then minus the derivatives of constant, which is 1, is always 0. So the answer is only 2x. Okay. Next, I will apply the what's that, product. Okay. So we have derivatives of f of x multiplied by g of x. So that is, copy the first function, then multiply by derivatives of second function, plus copy the second function, then derivatives of first function. Okay, let's make as example. Derivatives of x squared multiplied by 2x. Okay, so your first function is x squared, the second function is 2x. Okay, so let's copy the first, which is x squared, then derivatives of 2x, that is only 2 because 2 times 1, only 2. Then plus, copy the second function, so which is 2x. Then the derivatives of x squared, which is the power rule. So we have to multiply by 2, then x, because 2 minus 1 is 1. No need to write 1 here. Okay, then let's simplify. So x squared times 2 is 2x squared plus 2x times 2x, that is 4x squared. So the answer is, since they are similar, so that is 6x squared. Okay? And our last rule for the basic derivatives rules is the quotient. So we have for number 6 is quotient rule. Okay, derivatives of f of x all over g of x. So your numerator will be, copy the g of x, second function, then derivatives of first function, then write minus, and copy the first function, then derivative of second function, all over square root of your second function. Yan. Alright, I'll give you example. So So derivatives of d over dx, or derivatives of x plus 1 over x squared. Okay, so first you're going to copy the second function, then multiply by derivatives of for first function. So x plus 1, since x is 1, then 1 is 0. So 1 plus 0 is 1. Then minus, copy the first function, so x plus 1. Then multiply the derivatives of your second function, which is x squared. So we're going to apply the power rule. So x squared is, so since the exponent is 2, then x, 2 minus 1 is 1. So that is only 2x. Then the squared of your second function, which is x squared, then squared, equals to, so x squared times 1, that is x squared, minus, okay, minus, we have to do the distributive property. So 2x times x, that is 2x squared. Okay, next. So 2x times 1, that's 2x. This is applicable for subtraction. That is minus 2x. Okay? Then, all over x to the x squared to the second power. So power to power, that is x raised to the fourth power. Okay, let's simplify. Okay, look at the like terms. So x squared minus 2x squared is negative x squared minus 2x over x to the fourth power. We can simplify this also. So the common is, we have common for your numerator, which is the x. So let's have negative. So we have x here and minus 2 over the x to the fourth power. Sorry. Ayan. Okay. So we have to cancel this. This is 3 and this is only 1. So you have now, the answer is, so negative x minus 2 all over x cubed. So this is the derivatives of x plus 1 over x squared. So this is derivatives of the x plus 1 over x squared. So here,